Alright, this is the third video on section 2.4, talking about arc length and also the surface area. So we're going to go ahead and look at the definition of the area of a surface of revolution. So if we let y equals f of x have a continuous derivative on a closed interval AB, the area S of the surface of revolution is formed by revolving the graph of f about a horizontal or vertical axis. So here would be our function f of x from A to B, rotated, we'll say, around the x-axis. R of x is kind of like your radius, so that's the distance between f and the axis of revolution. So there it is. Most of the time, that's going to be your function f of x. Okay, and so I guess to try to motivate the formula just a little bit, you're going to be rotating the radius around, and then maybe we can have like a little bit of an arc length segment there. And so not surface, but the circumference of a circle. So we'll rotate that around, and so the circumference of a circle is 2 pi r. So the 2 pi rx, that's going to be kind of your circumference, and then the square root of 1 plus f prime of x squared. That's the same thing as y prime squared. You can think of that as your arc length, and so we can take a little itty bitty piece of arc length, and we'll rotate that around the 2 pi r, and then times that little bit of arc length. That's going to give us our surface area, and then we can certainly do that if it's in functions of y, so that'll work as well. So let's go ahead and do an example here. So we're going to find the surface area or find the surface of revolution, so we can find the surface area generated by y equals 7x cubed on the closed interval 0 to 2.3, and then we're going to rotate this about the x-axis. So our surface area formula is 2 pi integral from A to B, r of x square root of 1 plus y prime squared dx. So we'll do a rough sketch of our 7x cubed, so there it is. Rotate that around the x-axis. Our radius function is simply 7x cubed. Y prime is going to be 21x squared. And so our surface integral here, or our integral to find the surface area, is going to be 2 pi integral from 0 to 2.3. R of x is going to be 7x cubed, 1 plus 21x to the second power squared dx. So that's going to be 14 pi, slide out the 7. 0 to 2.3, x cubed, 1 plus 441x to the fourth dx. This is perfect for u substitution. U equals 1 plus 441x to the fourth. So du is equal to 1764x to the third dx. Solving for dx, you have du divided by 1764x cubed is equal to dx. So we have 14 pi. Let's go ahead and convert our limits. Lower limit is x equals 0. So the upper limit is going to be, new lower limit is going to be 1. Old upper limit was 2.3. New upper limit is going to be 1,234,1.98881. Okay. Still in the integral is the x cubed, and then the u to the 1/2 power. Dx was 1764x cubed. Oops, we went too far. Okay. So the x cubes are going to absorb, and I think we're going to go ahead and write that on the next page anyways. Next slide. Yeah, we just rewrite it here. Okay, so go ahead and slide out the 1764 in the denominator. 14 is going to go into 1764 126 times. It's going to have pi over 126. Integral from 1 to 1234, 1.9881. U to the 1/2 du. So it's going to be pi over 126. U to the 3/2 divided by 3/2. Evaluated from 1 to 1234, 1.9881. So pi over 126, take the reciprocal of the 3/2, 2/3. That's going to be 12341.9881 to the 3/2 minus 1 to the 3/2. And so that's going to be approximately 22,791.1079, and that's going to be units squared for our surface area. Okay. Alrighty. Well, that's it for this one, and we'll see you next time.